Now we look at 9.2, conclusions and consequences for a hypothesis test. There's 4 possible outcomes of a test. They're laid out in the table for us. If we look at the 2 possibilities for our null hypothesis, it can actually be true or it can be false. So if the null hypothesis is true, our conclusion could either be we reject the null or we do not reject the null. Okay, so let's look at this assumption that the null is actually true. Now, if it is true and we do not reject it, then that is a correct conclusion. Okay, the null is true and we have not rejected it. We've said that there is not enough evidence to reject that hypothesis. Okay, if we are still under the assumption that the null is true, but we reject it, then we have made an error. Okay, that's incorrect. Okay, and we call that error, we call that a type 1 error. And that is when we reject a true null hypothesis. Okay, now let's look at when let's assume that the null hypothesis is actually false, okay? And I guess we could also say then the alternative is true. Well, if it is false and we do not reject it, well, that is incorrect. Okay, so we're not rejecting something that's false. That's an error, and that is a type 2 error. Okay, we don't reject something that's false. And then the 4th thing that can happen is the null hypothesis is actually false and we reject it. And that is a correct outcome, a correct conclusion. Let's define these 2 types of errors more specifically. A type 1 error is when we reject the null hypothesis when it is actually true. And there's a probability that we assign to this, and actually it is the significance level that we choose at the beginning of the test. So we choose the probability of a type 1 error. So this alpha is typically one of those 3 values. So, you know, like 0.01, 0.05, 0.1. If we want to write that in probability notation, we would say the probability that we reject the null hypothesis, given or assuming that it is true. The null hypothesis is true. And that probability is equal to whatever we have chosen for alpha. All right, so that significance level is the probability that we make this error. So we can choose, we can decide what probability we want there to be. Okay, type 2 error, that is not rejecting the null hypothesis when it is false. And the probability of a type 2 error we refer to as beta. We're not going to calculate that value. It's something that we do have to calculate. It's not like alpha where we choose it. And so we're going to refer to it as this probability, but we're not actually going to be looking at values of it. All right, in probability notation, we're going to write that a type 2 error's probability is the probability of not rejecting the null given that it is false, the null is false. And that probability is, we refer to it as beta. So part of the reason it's not straightforward to write down an exact value for beta is that we have to choose alternate values for our parameter to equal in the null hypothesis, and then we calculate beta. So it's not just one value, it's one value associated with alternate statements of the null hypothesis, or our parameter equaling alternate values. So there's kind of an infinite number of values that beta could be. Okay, now, well, we can't actually calculate beta. We can say the following: because these are probabilities of errors, alpha and beta should be as, well, we want those to be as small as possible. Okay, now another measure of the test is something we call the power of the test. And it is this probability that we get by taking 1 minus what beta is, all right? Assuming if we calculate a specific value, then we can write down something called the power of the test. Okay, the power of the test is a probability, and it's a probability that we reject the null hypothesis when it is not true. So it's giving us the probability of something that is correct, something that is a correct outcome, a correct conclusion. If we look at these next couple lines here, beta is the probability of a type 2 error, all right? In other words, it's the probability of not rejecting the null hypothesis given the null hypothesis is false. So if we take 1 minus beta, we're calling that the power, okay? It's going to be the probability of the complement of the type 2 error. And that is the probability of rejecting the null hypothesis given the null hypothesis is false. So finding that complement, the given, what we're assuming has already happened, which is true, stays the same. All right, the complement is just the opposite thing coming before that. Okay, now given that this is a probability related to something that's correct, do we want to maximize that or minimize that? Do we want to maximize or minimize the power of the test? All right, well, we want to maximize it, all right, which in turn is going to make beta as small as possible. Now, even though we're not calculating this value, there's one way we know that we can increase the power of the test and therefore decrease beta, and while keeping alpha the same, and that is to increase sample size, or increase n. Okay, let's do some practice. Let's look at this scenario. Previously, an organization reported that teenagers spent 4.5 hours per week on average on the phone. The organization thinks that currently the mean is higher. 15 randomly chosen teenagers were asked how many hours per week they spend on the phone. A sample mean was 4.75 hours with a sample standard deviation of 2. Okay, it can be helpful to write out the null and alternate hypotheses before we identify what the type 1, type 2 errors are. So the null here is, that mu is equal to 4.5. And then the alternate is, it's reflecting what this organization thinks. They think that it is higher. Okay, so okay, so we want to go through these 4 statements and identify what they reflect. So we can decide that they're correct, or we can decide that they reflect a type 1 or a type 2 error. And then we're going to want to figure out, well, which one of the correct ones is identifying the event that the probability power, the power is associated with. Okay, so let's just read through each of these. To conclude that the current mean hours per week is higher than 4.5 when in fact it is higher. Okay, so we're concluding the same thing as what's true. So we're concluding that it's higher when it is higher. So this is correct. And let's look at B. To conclude that the current mean hours per week is higher than 4.5 when in fact it is the same. Okay, in other words, it's the same. It equals 4.5. Well, that's incorrect. And so we have to figure out, well, which error is it? Well, we are concluding that the current mean hours per week is higher than 4.5. So that means we're rejecting that it's equal to 4.5. So we're rejecting the null hypothesis when it's actually true, when it actually is, the mean is 4.5. Okay, so think back, look back at your notes. Which kind of error is that? Okay, well, hopefully you're concluding that that is a type 1 error. Okay. Okay, the next statement, to conclude that the mean hours per week currently is 4.5 when in fact it is higher. So we're concluding that the null is true. We are not rejecting the null, but in actuality, the null is false. So we're not rejecting a false null hypothesis. That's an error, and it is the type 2. Okay, so that goes with C. All right, next one, to conclude that the mean hours per week currently is no higher than 4.5 when in fact it is not higher. Okay, that's a correct statement. Okay, or that's reflecting a correct outcome. To conclude that the mean hours per week is no higher than 4.5 or it's equal to 4.5 when in fact it is not higher. It is equal to. Okay, let's go back and look at those correct outcomes and determine which one reflects the power of the test. So the power of the test is the probability that we reject the null hypothesis when it's false, when it's not true. Okay, so if we look back at A, we conclude that the current mean hours per week is higher than 4.5 when in fact it is higher. Okay, remembering that the null is it's equal to 4.5, all right, we are rejecting that here. We are concluding that it's higher, and it actually is higher. All right, so it's A actually that reflects the power of the test. So the probability of that conclusion is 1 minus beta. Let's look at this example. When a new drug is created, the pharmaceutical company must subject it to testing before receiving permission from the FDA. Suppose the null hypothesis is the drug is safe. So let's write out the null and the alternate here. So we're just writing them in words. So the null hypothesis is that the drug is safe. So then the alternate is going to be the drug is not safe. Let's go through each of these statements and determine if they're correct or if they are an error and which one. So A says to conclude the drug is safe when in fact it is unsafe. Okay, so to conclude the drug is safe is to not reject the null hypothesis, all right, but it actually is unsafe. So we are making an error there. And so the error is we're not rejecting a false null hypothesis. So that is type 2. Part B, not to conclude the drug is safe when in fact it is unsafe. Not to conclude the drug is safe is rejecting the null hypothesis, and that's actually agreeing with what it actually is. It is unsafe. So there, that is a correct outcome. Part C, to conclude the drug is safe when in fact it is safe. That's also a correct outcome. And part D, not to conclude the drug is safe when in fact it is safe. Okay, so this is an error. We are rejecting the null hypothesis, but the null hypothesis is actually true. The drug is safe. That is a type 1 error. Now, determining which one reflects the power of the test. So remembering that the power of the test is the probability that we reject the null when it is not true. All right, so it's one of those correct options. So part B is where we reject the null, and the null is not true. So part B is the one that reflects the event that has the probability of the power. Okay, number 3 example. So here we're going to look at a jury trial as being like a hypothesis test. All right, so what we assume to be true in a jury trial, so it would be like the null hypothesis, is we assume that the defendant is innocent or not guilty. So that makes the alternative that the defendant is guilty. So here we're just going to write out the type 1 error and identify what its probability is. So a type 1 error is when we reject a true null hypothesis. So in terms of a jury trial, it would be to say, to conclude that the defendant is guilty. So conclude guilty when, in fact, the defendant is innocent. That null hypothesis is actually true. Okay, and that probability is alpha. Type 2 error. Right, the type 2 error is going to be to conclude that the defendant is innocent when, in fact, the defendant is guilty. And that probability would be beta. Now let's think about what outcome reflects the power of the test. So the power is the probability we reject the null and the null is not true. So if we reject the null here, we are saying that they're guilty and they are guilty. So the power is reflected in the outcome of concluding guilt when the defendant is actually guilty. Okay, last one. Suppose the null hypothesis, H naught, is the victim of a car accident is alive when he arrives at the emergency room of a hospital. So our null is this victim of the car accident is alive. And then that would make the alternate that he's not alive or he's dead. Okay, so we want to write down what would be the type 1 error. So the type 1 error would be to conclude we would reject a true null hypothesis. So we would conclude that the null is not true. So we're going to conclude that the patient or the victim is dead when, in fact, the victim of the car accident is alive. All right. that would be the type 1 error, and it has probability of alpha. Okay, type 2 error and its probability. So that is going to be to conclude that the victim is alive when the victim is actually dead. And that has probability of beta. Now, here's a good question to ask sometimes about these errors, because if we're making decisions based on the results of these hypotheses tests, we want to know what the consequences are if we make one of these errors. So this is a question, actually, this shows up in your WebAssign pretty often for many of your problems that you're going to do. But which error has the greater consequence here? All right, well, if a patient or a victim comes into the emergency room and the nurses and the doctors conclude that that patient is dead, but he's actually alive, they're not going to treat the patient. All right, and so maybe he wasn't dead to begin with, but if they don't treat that patient, he might die afterwards. So in this case, we would say that the type 1 error would be the error with the greater consequence. But it's not always the case. There are some cases where a type 2 error is going to have greater consequence. Let's look at this example. A microbiologist is testing a water sample for E. coli. Suppose the null hypothesis is the sample does not contain E. coli. The probability that the sample does not contain E. coli, but the microbiologist thinks it does, is 0.012. The probability that the sample does contain E. coli, but the microbiologist thinks it does not, is 0.002. What is the power of this test? Let's write out what the null and alternate hypothesis would be. They give us the null as the sample does not contain E. coli, so we'll say no E. coli for the null hypothesis, and for the alternate, then it is the sample does have E. coli. So we'll write it out like that. Now we're given a couple of outcomes and their probabilities. So let's write down those outcomes in probability statements, and let's write it down in terms of the null hypothesis, what's happening with the null hypothesis. Okay, first one, the microbiologist, or the probability the sample does not contain E. coli. So does not contain E. coli. That is sort of the given event, and not containing E. coli is reflecting the null hypothesis. Okay, so that's the given event, so we can fill that part in. The null hypothesis is true. All right, but the microbiologist thinks it does. So the microbiologist is rejecting the null. So this is the outcome where we reject the null, or the microbiologist rejects the null, given the null is true. Okay, so this outcome, what does this reflect? It's an error, right? We're rejecting the null and when it's true, and that is a type 1 error. So we can say this right here is type 1 error, and we are given the probability is 0.012, and we know that that is the significance level alpha. Okay, so that doesn't help us with the power, right? Because the power is 1 minus beta. The other outcome that's given to us, let's write that down in a probability statement in terms of the null hypothesis. The probability that the sample does contain E. coli, but the microbiologist thinks it does not, is 0.002. Okay, so the given thing is the sample does contain E. coli. So that means that the null is false. So what we have given is the null is false. It's not true. Okay, but the microbiologist is concluding that it does not have E. coli. So the microbiologist is not rejecting the null. Okay, that is an error, and that is the type 2 error. Okay, so we're given that probability is 0.002, and because it's a type 2 error, that 0.002 is beta. Now we can get to the power of the test. So the power will be 1 minus beta, which is 0.998.